Over the decades, global navigation satellite systems (GNSS) have experienced unprecedented growth due to the rapid development in satellite-based positioning and its application across various sectors. GNSS presents a much better option to collecting spatial data due to its global network coverage, 24/7 observation, and all-weather positioning system. In the mid-2000s, GNSS started gaining popularity in Ghana due to the pressing need of developing a common reference system to aid mapping and the production of geographic information. Various stakeholder meetings were held on regional and national bases to develop this concept further. In regards to this, Geo Tech therefore established 7 core stations across Ghana, one in Bogoso, located at Golden Star, another in Damai, located at Goldfields Ghana Limited, and these were installed to aid in volume computation, setting out, and all other survey and civil works. Another was installed at the University of Mines for educational purposes. Another core station was installed at the Ghana Space Science and Technology Institute, which is atomic energy, to help in measuring the ionosphere and to assess the degree of tectonic movement. 2 core stations were also installed at the premises of the Lands Commission in Accra and Ho, and this was to aid in cadastral surveying for land demarcations, mapping, and all other survey works. In the last quarter of 2021, Geo Tech partnered with GMX International, an Israeli company with vast experience in coarse network development. This partnership has birthed the biggest GNSS network in West Africa, boasting of 52 stations across Ghana, with each station having a coverage radius of 70 kilometers, thereby giving us a 90% nationwide coverage.
Before we embarked on the installation of the cores to form the cores network, we came out with some rubrics for selecting the location. And this was based on the distance between one station to another. We tried to maintain a minimum distance of 50 kilometers to enhance the accuracy of the cores network. And then when it comes to mounting the monuments on the building, we decided that the building should be older than 10 years to avoid any future tectonic movement. Cellular network was of great importance because each individual station has a SIM card and has to have reception to transmit data from the station to the cloud server for use for NTRIP and RTCM corrections broadcasting. We have an open market for GNSS products in Ghana, so we don't have any specific brand. Therefore, we've made available mount points for every brand, every possible brand. So we have dedicated mount points for CMR, CMR Plus, CMR RX, those who take care of Tremble, and then we have RTCM for Leica and then Sokia Topcon. We even have NCT mount points dedicated to John Deere proprietary correction data formats. A nationwide cores network has immense benefits. 1. Data would always be available 24 hours for static. And also for RTK, we have a transmission 24 hours as well. Another issue to consider is in traditional surveying, a surveyor would have to purchase a base and a rover before he can do an actual survey. So, having a functioning core station reduces cost because the surveyor does not have to purchase a base station. He gets his corrections from the network, therefore reducing cost of survey works. With a nationwide network, of course, we have harmonized data sets. Since all corrections will be coming from one source, we no longer have to use traditional pillars or beacon for surveys. Therefore, accuracy can be controlled. In land administration, GNSS or the cores network could be used in cadastral survey, civil works, and GIS works as well. In the energy sector, it can be used to address the energy distribution challenges through the use of a robust GIS database. In the transport sector, it can be used to improve connectivity through infrastructural development. In the utility center, it can also be used for mapping. The same applies to the telecommunications sector.
The future of GNSS is to have a network that is intensified to give 100% landmass coverage and shorter base length between each core station. It is our hope that this core network will also be adopted and standardized by the Lands Commission for cadastral survey, aerospatial, and other geospatial related applications. Other geospatial milestones Geo Tech has enjoyed include the development of 7 transformation parameters that are used for transforming WGS84 GPS data to the National Grid System, which is CLAC 1818 modified. Another milestone is the mapping and inventory of all feeder roads in 6 regions of Ghana, development of GIS data for mapping for empty and cell sites, and development of GIS data for mapping of Shell stations in Ghana. Geo Tech is a firm believer in building the capacity of geospatial enthusiasts, and we have done this through initiatives for students and professionals. For students, they are able to undertake internships, placements, or training. And for professionals, Geo Tech usually organizes conferences or workshops to strengthen the capacity of these professionals.